Konnichiwa in Japan. Welcome to this outreach event of the German-Japanese Energy Transition Council. My name is Johanna Schilling. I'm Managing Director of ECOS, which is the organizational secretariat of the GJETC in Germany. And I'm very honored to guide you through today's event. Now, here's some technical advice for you who are participating online. For the Japanese interpretation, please click on the globe symbol in your menu bar, the Zoom menu bar, and select Japanese. If you want to hear English, to stay with the English original, just click on English. Thank you very much. Now, our today's topic is approaching carbon neutrality in times of crisis. The ongoing war in Ukraine has moved the urgent reduction of dependence on fossil energy even higher on the political agenda in Germany as well as in Japan. And in the presentations and discussions today, we would like to shed light on results from studies carried out by the GJETC. And these studies are, we think, relevant for decision makers in these difficult times we are all facing. Now, I would like to ask Professor Tatsuya Terasawa, who is Chairman and CEO of IEJ, of the Institute of Energy Economics, Japan, and also co-chair of GJETC, to just explain to us shortly what is on the agenda of our today's outreach event. So please, Terasawa-san.
Okay, thank you very much, Joanna. Good morning in Germany and good afternoon in Japan. My name is Tatsuya Terasawa, the Chairman and CEO of IEJ. First, I would like to thank all of you for participating in this fiscal year's first outreach event for GJETC, the German-Japanese Energy Transition Council. The GJETC was started in 2016, and the purpose of GJETC has been to conduct joint studies to provide policy recommendations for the two governments to lead us to the net zero goal. Every year, GJETC has been selecting several topics for joint studies. For the last fiscal year, ending in March of this year, we picked three topics as you see on the screen. The first one, distributed energy systems and the role of batteries. And the second one, decarbonization of steel sector in energy intensive industry. And the third is a long-term scenario analysis up to 2050. Today, we will have the results of the three topics, the research results to be shared with you. Among these topics, the third topic, the long-term scenario analysis, would be of particular interest. But this study was conducted before the war in Ukraine. So I'm asking Professor Peter Hennig and also Dr. Carsten Roll of BDI to provide us the update of the situation. And that comes on the fourth point. So once again, we'll have the results from our joint studies conducted in the past fiscal year to be presented, coupled with the update following the war in Ukraine by Professor Peter Hennig and Dr. Carsten Roll of BDI. Following these presentation results, if we can move on to the next slide, we will have a discussion about the implication of the war in Ukraine for Germany and the EU, and the Japanese energy security and the climate strategy, both for Japan and Germany. And for this, myself, Tatsuya Terasawa, will provide inputs as well as from Professor Peter Hennig, and we will have short comments from Professor Jun Arima and Felix Matthews. The global climate issue challenge is very important, but especially following the war in Ukraine, we have to think about energy security at the same time. And after these presentations, we will have time to receive questions from the audience, and hopefully we'll have a very interesting and constructive discussions today. I hope through this discussion today, the results would help us come up with better policies, business decisions, and better researches. So I look forward to today's discussion. Thank you very much for your participation.
Thank you very much, Terasawa-san, for just explaining the agenda and the urgency of today's topic. Now, I would like to hand over to the German co-chair of the GJETC, which is Professor Peter Hennecke, former president of the Wuppertal Institute for Climate, Environment and Energy. And I would like you to give a welcome to all of us.
Thank you very much, Johanna. Good morning in Germany. Good morning in Japan. This is an outreach event of the GJETC with a particularly important question in a crisis situation. Can we combine measures against the energy crisis with a higher level of ambition to emerge from climate emergency? This question is currently being debated on a global level as well at the COP27 in Sharm el-Sheikh. And as prosperous and leading industrial countries, Germany and Japan have a special responsibility to contribute to problem-solving solutions. Since 6 years, the GJETC has analyzed decarbonization processes in both our countries through an independent, research-based exchange of knowledge. Our work is supported by the Ministry of Economic Affairs and Climate Action in Germany and by METI in Japan. Today, we are presenting some of our studies and results, but please visit our website, gjetc.org, for more information. Thank you so much and good discussions.
Yeah, thank you very much, Peter. So let's come to the first part of our event today. As Terasawa-san explained, we would like to present results from the studies conducted by the GJETC. And we'd like to start with the study on the role of batteries towards carbon neutrality. So the question is, how can distributed electricity storage contribute to balancing supply and demand in power markets, as well as in power grids? So this is actually very relevant if fossil fuels are replaced more and more by fluctuating renewable energy. So we need this decentralized energy storage capacities. Now I'd like to ask Stefan Thomas, the director of the research group on energy transport and climate policy at Wuppertal Institute and also council member of GJETC. And his research partner at the Institute of Energy Economics, Toshiya Okamura, to present this study to us. Now, one hint at this point, the presentations we are showing today will be uploaded on the GJETC website after this event. And the full studies can already be downloaded from the GJETC website. So you can have a look at the website and find all the studies. Okay, now Stefan and Toshiya, please, your presentation.
Thank you very much, Johanna, for the introduction, and good afternoon to Japan and good morning to Germany. As Johanna said, this study was about the role of batteries towards carbon neutrality and how distributed electricity storage can contribute to balancing supply and demand in power markets and grids. Next, please. The study looked at 3 types of battery applications and their use for flexibility to markets and grids, and assessed technology and business models. One is, of course, operated by grid operators, grid-integrated large-scale storage, which then naturally has the primary use of system balancing and grid stability. But also batteries operated in buildings or industry, which of course have the primary use to optimize the operations of the buildings or factories, and also the storage capacity in battery electric vehicles with the primary use of transportation, show also a big potential for flexibility in the electricity system, with expected increasing deployment towards 2030 and beyond. To advance the main finding, there are not yet really business cases for these uses of these types of batteries, in both countries, but a few pilots in both countries. In addition to the use for the flexibility, we also addressed the potential of further using the batteries, especially from BEVs, as a second life in buildings or in grid integrated larger stacks and other reuses. And then also further into the future, the needs for battery recycling, but we'll not touch upon in this short presentation on these two topics. We mainly did country studies of the potentials for these three types of batteries and their uses on business cases, the status of application today and possibly in the future in 2030, and also aspects of regulation needed to enable the use of building and industry and vehicle batteries for balancing the power market and grids. So the next, please. Brief introduction to these three types of batteries. Grid integrated batteries are normally used at grid points that are often overloaded, and by taking up excess production for renewables energies during periods of congestion and releasing them at periods of non-congestion, they can prevent renewable energy generators from being shut down. Next, please. The uses in the grid are also shown in this graph at the bottom, but more important here in this graph is the top, which is the uses, the normal uses of why building owners or factories would install such batteries. And that is increased PV self-consumption, backup, energy arbitrage, reduction of demand charges, peak shaving, but with the right incentives and additional technologies in place, such as smart meters, they can be used to also serve flexibility in the energy markets and grids. And the next, please. Finally, for the battery electric vehicles, there are different ways of making them useful, also for the electricity markets and grids. We find that they are used maybe 5% of the time and need maybe 10% for charging. So 85% of the time they are free for potentially providing flexibility services. And the first step would be unidirectional control charging or smart charging. And then there are three further steps of bidirectional control charging, also contributing to the electricity supply either in a building or in a regional electricity system or in the supra-regional power grid, which is then here denominated as the full vehicle-to-grid option. Next, please. So briefly, the findings for Germany. We see that utility-scale batteries, the large-scale systems, have been operated for several years now in Germany. Around 70 were in place in 2019 with 460 megawatts of capacity. But the growth is not expected to be very high in the next years. There are also increasingly home batteries together with the increase in PV systems. It was 750 megawatts already, and some industrial batteries. And the market for battery electric vehicles is currently growing a lot in Germany, as in all of Europe. There are estimates that home storage systems could provide up to 10 gigawatts of battery capacity in 2030, and battery electric vehicles even up to 15 gigawatts, because the government plans for 15 million battery electric vehicles in 2030, and this compares to an estimated total transmission grid load of 80 gigawatts, which, however, will also increase in the future with electrification. So, but this shows that the combination of variable renewable energies and electrification also at the same time will provide the potential for flexibility to integrate this variable renewable energies, photovoltaics and wind into the system. So with this, I would like to hand over to my colleague Toshiya from IEJ for the rest of the presentation. Thank you.
Thank you. Next slide, please. Japan has different priorities and implementation stage in battery deployment. For the grid integrated storage like LSS, there is no clear deployment target. Also, the lower bottom, the EV battery, the Japan opts more wider choices in xEV deployment, notably hybrid EVs will continue to play major roles in the energy efficiency sectors until 2030. So compared with these LSS or the xEV, the battery deployment in the building sector, which is represented by home batteries or industrial batteries, HSS or ISS, the Japan has a closer relationship with the government and the industry, and they have developed a roadmap of the battery deployment in homes and buildings, both in newly construction and existing buildings. Next slide, please. This is the comparison of the two countries, the policies and the implementation stage. But I would like to highlight the lower bottom, different policy and priorities implementation stage, especially some battery standard. In Germany is going to follow the EU battery directive with environmental labeling and manufacturers' recycling obligations. Japanese government is trying to foster a technology and business competition to develop a better battery management and the production by allowing the industry voluntary guideline in the battery health assessment and the recycling. So these are quite different approaches. The different approach also connects to the country's EV deployment target, as well as the large-scale LSS deployment policies. Germany is going to develop many battery EVs, and also the industry will see the used battery EV batteries by 2030. Germany pilot projects in the EV battery repurposing or the recycling indicate that the repurposing EV battery may be more realistic in the large-scale repackaging because the battery EV batteries conditions will be very variable, and the disassembling and the repackaging will incur additional costs. Japan may have fewer used battery EV batteries and fewer large-scale deployments by 2030. So the government can still allow the industry to explore better technology and the business processes. Next slide, please. So the study conclusion has several findings. The first one, the distributed battery storage resources as a grid flexibility is both still in early stage. Only a few pilot projects can be found in 2 countries. The second findings, in order to allow distributed battery storage as a grid flexible resources, there are key issues in the additional costs of metering and control. And also we need to remove double grid use device in charging and discharging. So these 2 key issues should be addressed to foster more distributed battery storage as grid resources. Next slide, please. And the conclusion continues. The third point, especially in the regions with higher battery EV deployment target, EV charging load is going to stress the grid. The timing when to charge the EVs, like when there are plenty of renewable generation, and the location where the grid capacity is available the time and the location conscious battery EV charging is the first battery contribution to the grid. It is well before the batteries can contribute as flexible resources. So this smart charging, conscious of the grid capacity and the location, is one of the key factors towards 2030. The last fourth point, the used battery EV battery stock is going to become either tons of useful materials or minerals or tons of complicated wastes. So we will need to intensive discussions on the regulatory framework in the health measurement of the used batteries and the recycling, along with the battery manufacturers and the auto manufacturers. So these are the findings from the previous year's studies. So this concludes our presentation. Thank you.
Yeah, thank you very much to Stefan and Toshia for sharing the results. The link to the full study has just been posted in the chat, so please have a look at the website. And if there are any direct questions from you, the audience, regarding this study, you can post them in the chat, if possible in English. As we won't have much time today maybe to answer them in our discussion, I would ask Okamura-san and Stefan to just reply in the chat if there are any direct questions on this study. So thank you very much. Now, we are coming to the next study, which will be, yes, on another big issue that has become even more urgent these days. So that's the decarbonization of energy-intensive industries. And the next study to be presented shows potential roadmaps for decarbonization of the steel sector. The study has been conducted by Thomas Edison, researcher at the Wuppertal Institute, and Yoshikazu Kobayashi of the Institute of Energy Economics, Japan. Unfortunately, Thomas is ill today, so Kobayashi-san, it will be your duty to present the study just on your own. So please, your presentation.
Thank you, Johanna-san, for your kind introduction. I'm Yoshi Kobayashi of the Institute of Energy Economics, Japan. Unfortunately, as Johanna-san said, Mr. Thomas cannot attend today's workshop, so I will present the entire slides of the presentation material. The structure of my presentation is shown in the slides. I will briefly overview the German steel industry and its decarbonization roadmap, and I will do the same for Japan. Then I will compare the two countries' decarbonization roadmap, and will conclude with policy recommendation to both countries. Next, please. Okay, this is industry overview of German steel industry. The largest company is ThyssenKrupp, followed by ArcelorMittal and Salzgitter. Germany has 6 blast furnaces across the country, and with many electric arc furnaces. Majority of the German steel products are utilized for automobile and construction and machinery sectors, and metals as well. And what is more important is that how Germany produces steel. According to our research, around 70% of German steel product is produced from blast furnace, which is more difficult to decarbonize. So next, please. This is a decarbonization roadmap of German steel industry. Just as the national target of Germany, German steel industry also aims to achieve carbon neutrality by 2045. Key technologies to realize such decarbonization path is electrification of steel making, direct reduction technologies with hydrogen, and CCUS application. to some extent, CCUS with coupled with bioenergy. According to the scenario analysis made by Wuppertal Institute, German steel industry can even go carbon sink in 2045 by utilizing the bioenergy with CCUS technologies. Next, please. Okay, I'd like to move on to Japan. Japan also has many blast furnaces, steel mills, but most of them are concentrated on the Pacific coast areas, which we call Pacific Belt. Japanese steel products are utilized in various sectors as shown in the pie chart. And the big difference from German steel industry is that Japanese steel industry exports around 40% of products to abroad. So in that sense, Japanese steel industry faces fierce international competitions. And this is also common aspect or characteristics with German industry. Around 75% of Japanese steel production is produced from direct, blast furnace route. So both countries depend on the blast furnace route. So we have common challenges to decarbonize the steel making process. Next, please. Regarding the decarbonization roadmap, Japanese steel industry aims to achieve carbon neutrality in 2050. And adopted technology will be mostly the same as German steel industry. Japanese steel industry considers to utilize direct reduction technologies with CCUS applications. Next, please. Okay, these are the comparisons. I will focus on the differences side because commonalities will be less interesting to the audience. Regarding the differences, the Japanese steel in the decarbonization roadmap put more emphasis on the public-private partnership as seen in the Course 50 project. Both industries assume to adopt the CCU, but the final products are a little bit different. German steel industry considers the direct reduction process by natural gas as a transition technologies. And also German steel industry seriously considers the bioenergy with carbon capture and storage or utilization. Both countries' industry assumes to utilize hydrogen, but the German steel industry put more emphasis on the green hydrogen, while the Japanese steel industry considers utilizing both green and blue hydrogen. Zero emission electricity will be very important, but the major source of zero emission electricity will be renewable energy in case of Germany, while in Japanese case, we will utilize not only renewables, but also nuclear, hydrogen, and ammonia. Next, please. This table shows the economics of different decarbonization technologies. If you look at the abatement cost, the cheapest one is high thermal and CCS technology, but this technology cannot fully decarbonize the steel making process. So we consider that the direct reduction will be a good compromise. both in terms of abatement cost and decarbonization potential. Next, please. The next two slides is kind of a conclusion of this study. Firstly, on the policy recommendations. The policy recommendation to Germany is provided in 5 dimensions. In the economic dimensions, safeguard issues, competitive issues should be addressed. And in that sense, international alliance may be important. Technological dimensions, support for R&D will play a very important role. In the infrastructure dimensions, promote circularity in steel production will be necessary if electrification plays a larger role in the future. On the societal dimensions, social hardship caused by transition to the decarbonized steel will be somehow managed. On the environmental dimensions, establishing ecological safeguards, and we need to minimize the potential environmental hazard by having a more, for instance, renewable energies and hydrogen productions. Next, please. Regarding the policy recommendation to Japan, some recommendations are common to the German recommendations, like cost competitive, innovative steelmaking technology and necessity of public support. And in addition to that, clean hydrogen has to be supplied at competitive cost with sufficient volume and supply reliability. We need to develop and arrange legal and regulatory framework for CCUS applications. And electricity required for electric arc furnace needs to be zero emissions, as we planned in our power generation mix. Financing should be secured by providing a clear roadmap for decarbonization. And finally, the cost increase to produce a decarbonized steel has to be shared by both producers and consumers. Okay, with that, I thank you very much for your attention.
Yeah, thank you very much, Kobayashi-san, for presenting the whole study to us, which gives indeed interesting insights into the common challenges and political recommendations, but also the differences regarding decarbonization of the steel sector. Thank you very much. Now we come to the third study we would like to present today. This is a comparative analysis of long-term scenarios discussing decarbonization strategies in Japan and Germany. And as Terasawa-san mentioned in his introduction, we have now the energy crisis caused by the war in Ukraine, and this might also have implications on decarbonization roadmaps. So a kind of update of this study would be needed. So now I'd like to ask my colleague Lotte Nowotnik of the Wuppertal Institute and Hideaki Obane of the Institute of Energy Economics Japan to present the third study.
Thank you, Johanna. Yes, as you already explained, we will briefly present the results of the study on long-term scenarios in Japan and Germany. To this end, next slide, please. We have selected 4 scenarios each, and here you can see the selected ones for Germany. While most of the scenario studies we analyzed have been published shortly after or before the revision of the German climate targets to become climate neutral until 2045, only the Green Supreme scenario published by UBA has been published already in December 2020. We still considered this scenario because it focuses particularly on energy efficiency and also aspects such as material efficiency and circular economy. Next slide, please. So among the key assumptions we can make of is first of all, the greenhouse gas emission reductions, and also an increase of battery electric vehicles, as well as an increase of heat pumps, and also an increase of the renovation rate of building stock, as you can see here. And based on these assumptions, we can make out 3 core results, which you can see on the following slides. Next slide, please. First of all, the final energy demand is reduced to approximately 60% until 2050 as compared to 2019. And here you can see that, as mentioned before, particularly the Green Supreme study by UBA is calculating a considerably strong reduction of the energy demand. The second key result, as shown on the next slide, is the energy mix, and particularly in the electricity generation, you can see that almost 100% are said to be generated by renewable energies or based on renewable energies. And here, particularly photovoltaic and wind onshore is important. Next slide, please. In addition to this, and particularly why this kind of large share of renewable energies in electricity is important, is that the overall need for electricity is going to increase because of the electrification that is estimated. Here you can see an increase of the total final energy demand from 41 to 51% until 2045. On the bottom, you can see that, electromobility, as well as the increase of heat pumps, but also the increased use of electrolyzers is contributing to this increased demand. Yes, so although we recognize these very promising scenarios, we still have some shortcomings to point out, which you can see on the next slide. First of all, energy efficiency first is only partially included, and along with this also aspects such as material efficiency and circular economy strategies, and rebound and lifestyle effects, as well as sufficiency policies. And another aspect we would like to point out are the distributional effects for households, companies, and regions that are not thoroughly reflected, but necessary to reach a just transition. Finally, another aspect is the dependence on energy import that is not thoroughly discussed. And this is not only important in the current situation in terms of the dependence on gas coming, for example, from Russia, but also with regard to the expected increase of using hydrogen. And in this regard, of course, also the infrastructure and possible target conflicts has to be taken into consideration. And finally, also the ambitious level of reaching actually not exceeding the 1.5 degree target has not been discussed. So let's take a look at the Japanese scenarios now. Hide, please.
Okay, my name is Hideaki Obane from IEJ. Then I'll explain the Japanese long-term scenario. In Japan, the several organizations or institutes show their own scenario in the government committee. This slide shows generated electricity in 2050. In the energy mixes, the share of renewable energy is approximately 40% to 100%. Not like Germany, the many Japanese scenarios considers that not only renewable energy, but also the other low emission technologies such as nuclear power plant, gas and CCS, the ammonia power plant to cover the total electricity demand. The next slide, please. But although the many German scenarios show the renewable energy 100 scenarios, in Japan, if try to realize the renewable energy 100, the PV systems or wind turbine would have to be installed in restricted areas, such as farmland or forest. The land use issue will be more critical. For example, in the light chart in this scenario, the installed capacity of onshore wind in renewable energy 100 scenario, if the wind turbine is installed only in woodland or bare land to avoid the negative impact to local environment, only 25 gigawatt capacity is possible. But further wind turbine will be installed, they must be installed the forest or farmland. I think the renewable energy 100 is not necessarily impossible, but we have to carefully consider the local environment or social acceptance. The next slide, please. This slide shows the final energy demand. Currently, in 2020, the total final energy demand is approximately 300 million TOE. But many scenarios considering the carbon neutrality show that the final energy demand is reduced to 2/3 compared to 2020. The percentage of electricity will also increase up to 40 to 50%. So the result shows the saving energy or electrification is important. The next slide, please, and I will pass to the German team.
Yes, to sum up, we can say that the reduction or the reduction of primary energy demand is important in both scenarios in Japan and Germany. However, in Germany, it is calculated to reach already a reduction of 50% until 2045. While in Japan, it's a little bit lower. And also in terms of the share of renewable energies in generated electricity, while we can also see some scenarios in Japan reaching up to 100%, most of them are somewhat lower. And as pointed out by Hide, we can also say that the Japanese scenarios already also include nuclear power, while the German scenarios all consider phasing out of nuclear and coal. With regard to residual emissions that need to be tackled and that can hardly be avoided, in the Japanese scenarios, the focus is on DAC and CCS, while in the German scenarios, natural sinks, BEEC and DACCS is considered for the remaining just roughly 5% of residual emission. Now, in the current situation, the war in the Ukraine put into question the supply with natural gas as bridging technologies, which the German scenarios considered. And however, this actually shows how important it is to further focus on energy efficiency and material efficiency and the aspects of the circular economy, while not neglecting, of course, the importance of a just transition, as Hide pointed out, which is very much important for the acceptance of the transformation we need. Thank you very much.
Yeah, thank you very much, Lotte and Hideaki, for giving an insight into that study. Now, Carsten Rolle already joined us here. He is the head of Energy and Climate Policy Department at the Federation of German Industries, the BDI. And well, we heard a lot about the roadmaps now in Germany and Japan. Well, the CO2 reduction targets are still being confirmed by policymakers in Germany as well in Japan. And it is still to be seen how much the current energy crisis will affect those roadmaps. Actually, the BDI also drafted a kind of scenario, the BDI Climate Path 2.0. And well, Mr. Rolle, we are looking forward to your thoughts and comments on the current scenario and whether or not the current energy crisis will have effects on that or not. So please.
Thank you very much, Ms. Schilling, and good morning to everybody. In fact, I'm very grateful that the colleagues already collected some of the major results of our study, as well as of other studies that came up last year to show how the transformation in the next years, up to 2030, up to 2045 in Germany, could look like. And in fact, if you take all these studies together, with it is ourselves, DENA, Agora, you could also add the one from Acatech, the Academia of Sciences, and the Ministry of Economic Affairs and Climate Change. These studies do not differ that much when it comes to the technology mix of the future. And this is maybe one of the good news for policymakers as well as for companies. We are more or less clear what to do technology-wise. There's slight differences in the share of hydrogen in the future, but basically it is more a question of how to really incentivize these things and how to build up the energy infrastructure a lot faster than in the past to make this doable. And these were the two key results also of our study that I showed, I think, last time when we met with a lot of slides. That's why I decided this time just to speak and add a few comments on that. The two main challenges that we saw with the next years to come are, first of all, how can we really make sure that the energy infrastructure will be built a lot faster than the past? I think our study was the only one that translated these technologies into investment, and we came up with a figure of 860 billion euro extra investment needed up to the year 2030 for all of Germany, all sectors, to make the climate targets 2030 really happen, to make this achievable. And next to the infrastructure challenge for industry, especially the OPEX cost differentials, fossil to the green technologies of the future, were the second challenge that we want and have to bridge in order to be successfully in the future. Now, with the current crisis, we see, in fact, that the gas bridge, as the colleagues have said, is one of the questions. There are other questions I want to tackle at the end. But before, maybe let me briefly address the current crisis itself with a few words, because this is really what's keeping us busy. The energy crisis, which is, I think, at least for large parts of Europe and for Germany, German industry in particular, the most severe energy crisis that we're facing since World War II. This is really a challenge that no one of us had actually expected, with gas prices times 8, times 10, and even more compared to the years before. Same with electricity prices, and no signals of fast de-escalation in the next month to come. Nevertheless, I'm very glad that even in these times of crisis, our organization, BDI, on its climate congress this September, said this is not the time that we want to question climate targets, neither for 2045, getting climate neutral, nor for 2030. Although times are different and difficult, we will strongly believe that the direction is to be kept, and it is more now how to tackle different phases of a crisis in front of us. And basically, I see 3 different phases with different policy measures needed. Now, first of all, at the moment, we are tackling the immediate effects of the crisis of the next 1.5 years up to mid-2024. It's all about how to cushion the extreme price hikes, how to make sure that these won't have severe social effects, and also dangers on industry structures in Germany. Next to the prices, there is still, at least in times of a cold winter, a remaining risk of really having gas shortages and the need for curtailment. But with the gas savings that have been achieved in the past month, we now believe that this is of lesser likelihood than we've thought in summer. So if we keep all the efforts of the last month, we hope to get manage this winter without any physical gas shortage. Now, second phase is then the midterm perspective up to more or less 2030. And these times after 2024 to 2030, these times of significantly higher gas prices that will stay with us. We won't see gas prices of the past. That's at least our expectation. And especially we won't see, and we will see higher price differentials to US gas market and to the one in the MENA region. And what does this do with competitiveness of industry? What does that also ask for policy instruments when it comes to, for instance, market design and price structures, electricity price structures? We see companies now asking for PPAs, offshore wind designated PPAs as part of the solution. So industry is asking for new models of pricing in order to stay competitive in these surroundings. And third, then we're in the long-term perspective after 2030, of course, the way forward, how to get climate neutral and to build the infrastructures also for the 2030s when it comes to CCUS infrastructure, when it comes to hydrogen, ammonia infrastructures, and so forth. So this is what we have to do today in order to prepare for tomorrow. Addressing the very immediate price hikes, now we've seen in the past weeks, also with the Gas Commission, Felix Mattes and I have the pleasure to discuss day and night in the last weeks, a strong willingness of government really to address these hikes and to cushion the price hikes, by at the same time keeping the incentives to save gas in a balance in order to come through the next 2 winters. This is a huge package, is still somehow in the discussion. How does that fit also with the European rules, the competitiveness law and in the state aid guidelines? But with the solutions that government is now just in these days about to take, we hope to cushion the most severe effects and by that addressing the most immediate effects for the next month to come. When it comes to the midterm effects that I mentioned, I see several really challenges, and those go beyond the infrastructure speed up that I mentioned and the need for carbon contracts for different. Obviously, the price differentials between gas and green hydrogen narrow with higher gas prices to stay. But on the other side, we see increasing prices for a lot of technologies, whether for the salaries of craftsmen, for solar panels, for heat pumps. So the 860 billion euro investment that we've defined last year may already not be sufficient, as we see immediate pressure on these prices. Second, huge challenge, and that is really new, I think, over the course of the last 2 or 3 years with Corona and now with the Russia-Ukrainian war, is a call for more resilience. And this could be also a very interesting topic for, I think, our cooperation in the GJETC here, because there's a lot we could also learn from Japan, I believe, when it comes to the provision of raw materials and the way government and companies work together in making sure that we don't get too dependent from certain countries when it comes to raw materials and the raw material products and refinery products, whether it is rare earth, germanium. There are a lot of metals that are very much needed for the energy transition, that are highly concentrated on a few countries to supply, and where we fear, with all the geopolitical experiences that we've made, that these could be another challenge or threat for the future. And I guess with more cooperation of countries like Germany, Japan, Korea, on how to address these with long-term contracts, with other ways of securing the supply chain, this would be very interesting to discover in our cooperation. We see other challenges as the Inflation Reduction Act in the US and increasing trade barriers that will challenge also not only companies, but also the technologies to keep here. The hydrogen push that we've made in Europe and Japan that is challenged by the US, I think, with this act and a lot of money that they want to spend. So there are new moments in this debate. And nationally, as has been said, we're addressing a CCUS strategy as German government beginning next year in order to build up the other strategies, the other technologies here in Germany as well. So in the end, does the crisis speed up now the energy transformation? We've also asked our membership, and we do see both answers. We do see companies that actually speed up their efforts in electrifying their processes, in investing in energy efficiency. We see the steel industry that still sticks to their DRI plans and investments, even in these times. But we also see a lot of companies that cannot do with the high uncertainty at the moment, and by that postponing investment decisions for the next 1 or 2 years in times of high uncertainty. So mixed picture with the results from last year going forward, but I see a lot of potential for further cooperation in this group. Thank you.
Yeah, thank you very much to Dr. Rolle, also member of the council, of course, since quite a time. And thank you very much for the insight into the challenges, the current challenges from the point of view of the industry, and also the hints on what is needed also from politics. Now, I guess we have to speed up a little bit. Now we're coming to the second part of our today's outreach. I already saw that our audience made use of the chat. That is great. So please continue to use the chat to post your questions, and the answers will be made by our experts in the chat, and we will post questions and answers for you all in the chat, just to save time. Now we're coming to the second part, and we would like to shed light on the implications of the war in Ukraine for Germany and for the EU, and also for the Japanese energy security and climate strategy. So I welcome again our co-chairs of the German-Japanese Energy Transition Council to give some input on that question. So first input comes from Terasawa-san, please.
Okay, thank you very much, Joanna. I'd like to discuss the implications of the war in Ukraine for Japan's energy security and climate strategy. Certainly, it has had a major impact on our energy strategies, including the acceleration of renewable energies, strengthened efforts for energy efficiency, and renewed interest in nuclear. But in the interest of time, I would like to focus today on the question of the impact on fossil fuel, in particular LNG. Next slide, please. Japan's dependence on Russian energy is shown in the left side graph, which give you some more modest figures, like 8% of natural gas dependence on Russia. From the European perspectives, these numbers could be seen as very low, but it has had a major impact on our energy markets for sure, because the global price for crude oil, LNG, and coal, everything has gone up. So even though our dependence in terms of numbers on energy, Russian energy, has been rather modest, certainly with the rising energy prices, globally speaking, we are being impacted significantly. In addition, Japan is now facing a potential problem with the shortage of power supply. On March 22nd of this year, the eastern part of Japan came very close to a blackout due to the shortage of power. And as 40% of the power is supplied by gas-fired power plants in Japan, any disruption in the supply of LNG coming from Russia would certainly be very challenging for Japan to ensure the stability in the power supply. So in terms of number, we have smaller dependence on Russian energy, but the impact is significant. Next slide, please. Having said so, our impact has been relatively limited compared with the situation in the EU. And one of the biggest reasons is that we have had a long-term contracts in the procurement of LNG. 78% of our LNG is coming from long to mid-term contracts. These long-term contracts have ensured that we would have the access for LNG, as well as to have a much more stabilized cost for LNG. Typically speaking, most LNG imports for the long-term contracts are indexed to the crude oil market. So if you can see the graph, the red line graph and the red dots, the Japan's average import price for LNG has resembled the movement in the Brent crude spot market, which is much more stabilized and which is much lower than the spot market for gas in Europe or LNG globally speaking. So the long-term contracts have helped Japan to cushion the impact of the recent price hike. Having said so, these long-term contracts have been criticized in the past as being too much inflexible. So I think the question is to have the right portfolio of long-term contracts, mid-term contracts, and spots. Next slide, please. We believe that the war in Ukraine has impacted the fundamental structure of the global energy market. As you can see, Russia was a major supplier of all the energy sources. In particular, for pipeline gas, Russia was supplying 29% of the global market. And for LNG, Russia was providing 8% of the global market. So putting these together, Russia was providing 20% of the global gas market. Following the developments in Ukraine, and if we wish to pull out from the Russian supply of pipeline gas and LNG, from our perspective, since the size of the Russian energy has been so large, we cannot just simply pull out from Russia. We need to invest in non-Russian natural gas and LNG to replace or substitute Russian gas. But this would require a commitment of the buyers to procure those non-Russian LNG and natural gas. And I will touch upon this, but this will be very challenging. But on this slide, I would like to stress the importance of investing in non-Russian natural gas and LNG to substitute Russian gas. Next slide, please. The developments in Ukraine and the European gas market has impacted Asia. And since for our friends in Europe, you may not be able to see the impact on Russia, I will share with you some slides. The slide you see towards the left-hand side of this slide, you can see a dramatic increase in the LNG import by our European friends. At the same time, we are seeing a significant drop in the imports among China, India, and some of the other Asian countries. So the LNG that was flowing to Asia is now being shifted to Europe. And although the statistics are not available, we understand that for countries like China and India, as they reduce their import of LNG significantly, they would have to generate power somehow. And we believe that the consumption of coal in China and India should be expanding to offset the decrease in the LNG import. So while Europe is scrambling to get LNG from the global market, it is resulting in the shift from Asia to Europe in terms of the LNG flow, and leading to more coal consumption in some of the countries, potentially in China and India and some other Asian countries. Looking at the graph towards the right-hand side, this is the impact on the import price. And the country among these graphs, you can see Thailand.
Yeah, there seems to have been some instability in the connection. But there are actually 2 more slides to go for Terasawa-san, but yeah, maybe we need to use the time to give the word to Peter Hennecke, and maybe after that Terasawa-san can complete his presentation. Anyway, we will upload it on the website as always. So I would say, yeah, let's put Peter's presentation on the screen, and I welcome the German co-chair again, Peter Hennecke, to give his input from his point of view, which is the German input.
Thank you very much, Anna. Very sorry for this technical interruption. So let me follow up a little bit by framing the energy crisis from a global perspective. Next, please. If you look into the new world energy outlook and the net zero emissions scenario, 3 big messages are coming out in the long run and up to 2030. First one is we need a real energy efficiency revolution. Then we can reduce final energy by using energy efficiency and behavioral changes by 40% compared to stated policy scenarios. Next, please. The second message is we have to boost the introduction of a net zero sector of electricity up to 2040. And the last one, no new conventional oil, gas, coal projects and mines are needed if we foster energy efficient renewables and decarbonization technologies. Next, please. Within this context, Germany tried to combine its short-run and long-term reactions to the crisis. Energy savings are on top, 20% for gas, 10% for electricity. Gas storage have to be filled almost up to 100%. New LNG terminals floating will be built. Some coal power plants should be taken into reserve until spring 2024. And the last 3 nuclear power plants will be extended by about 3.5 months. All in all, energy efficiency and renewable energies and electrification will be boosted. And there are some intentions to phase out coal power plants, not in 2038, but in 2030. Next one, please. As has been said, the dependency on oil and gas imports from Russia are gigantic. And all these imports have been stopped at the end of the year. It's about 34% for oil and about 55% for imported gas from Russia. Next, please. And if we compare it to Japan, which has been mentioned by my colleague Terasawa-san, the German part, the German dependency is much higher. This is true for the European Union as well. But nevertheless, the price impacts are tremendous for both countries, for all the world. Next, please. What is important by this skyrocketing gas prices is the difference between Europe and the US. As we can see, there is a widening competitive edge for US gas, which has many implications for the further imports of LNG in Europe. Next one, please. The reaction of the European Union to the energy crisis was to enhance energy and climate targets compared to the package Fit for 55, which puts zero carbon target for 2050 and minus 55 by 2030. The reaction to the crisis, called Repower European Union, even increased the energy efficiency target to 30% versus the reference case, and increased the share of renewables up to 45% compared to the directive of 2018. All in all, these would reduce fossil and other fuels by about 40% up to 2030. Next, please. Of course, Germany had to react with very rapid measures to this challenge. Households and commercial buildings were encouraged to turn down heating. There was a heating ban for private indoor or outdoor swimming baths, bathing pools. Temperature default of 90 degrees have been decided for public offices. Outdoor illumination ban for public buildings have been put in place, and the ban for illuminated advertising installations all over the night. And further medium-term measures were introduced, for example, and mandatory hydraulic optimization of larger buildings. Next, please. When it comes to midterm energy efficiency and renewable policies, the public funding for retrofitting the building system was increased to 12 to 13 billion per year, expanding especially green district heating systems. The KfW standard of net zero buildings was increased to 55 compared to the standard for 2020-30 and to passive house standard in 2025. Industry got more funding for energy efficiency and low carbon processes, and the new transport ticket for 49 euros have been decided for local and regional transport nationwide. When it comes to renewables and electrification, all new heating systems must use at least 65 renewables from January 2024, which is a big challenge for retrofitting housing and heating systems. 80% electricity in 2030 has to come from renewables, about 600 terawatt hours. And the capacity of electrolyzers will be increased to 10 gigawatt in 2030. Last but not least, 15 million electric vehicles should be introduced in the market by 2030. Next, please. For the first time, Germany decided on an Energy Efficiency Act. The draft says that we will have binding targets for primary and final energy. There will be mandatory implementation for cost-efficient processes in companies. The role model function of the public sector will be increased for energy conservation, and the market for energy services should be unleashed. And last but not least, the waste heat from data centers should be tapped. Next one, when it comes to renewables, it's really a booster process, which has been decided in the so-called Easter package. The joint mission is to drastically speed up the expansion of renewable energy and to eliminate all obstacles and barriers. That means, for example, that renewables are now called as processes which are in an overriding public interest and serving public security, which should shorten approval processes a lot. Last but not least, we have an 80% expansion target for 2030, 80% from renewable electricity. and a tremendous increase in comparison to the past, a fivefold increase of the capacity each year for solar and for wind power. Next, please. On the import diversification part, LNG terminals were installed to diversify import dependency. All in all, this would sum up to 27 billion cubic meters total capacity. 2 of those are floating. There are permanent licenses until 2043, and there is an ongoing debate. Does this mean that there will be lock-in effects? Will they be hydrogen ready? The debate is going on. Next one. All these technical measures were compared with some specific phase-out decisions when it comes to coal, for example. In North Rhine-Westphalia, the government decided, together with the RWE, to phase out coal by 2030 instead of 2038. Some coal power plants, about 1.2 gigawatt, which were supposed to go off grid, are now prolonged to March 2024 as a reserve. And there is a pending debate whether we can phase out coal earlier in the eastern part of Germany. The last 3 nuclear power plants, as I mentioned, were put into a stretch mode until April 2023. All 3 were supposed to get off grid in 2022. And of course, this does not mean that there will be a renaissance to nuclear, but the phase out is decided and it will be terminated in March next year. Next, please. All these activities were joined by measures to avoid social and economic hardship. The expert commission on gas and heat has been mentioned. Carsten Rolle and Felix Mattes did a great job together with other experts to finalize a report in October 21st. The key measures, it's a very complicated and comprehensive paper, but the key message is there will be a protective shield of 200 billion euros against rising energy costs for vulnerable households and companies. There will be a break on gas and electricity prices, meaning that from March 2023 to April in 2024, the gas price break will be about 12 cents per kilowatt hour, capping 80% of households' monthly gas costs, and a little bit comparable for the electricity price, 40 cents per kilowatt hour, starting in January 23. To sum up, there were decisions on emergency and relief plans. Next, please. There is no change in midterm and long-term climate ambition levels. There's a double booster of energy efficiency and renewables, integrating energy sovereignty and climate mitigation. The transitional use of last 3 nuclear power plants up to March 2023 has been mentioned. The coal target, ideally by 2030, has been decided. We should avoid lock-in effects due to importing from new sources of fossil supply. And last not least, CCUS will be used only for carbon emissions from hard-to-abate sectors or from biomass energy. Thank you very much for your attention.
Yeah, thank you very much, Peter. Very interesting slides. Sorry that you had to rush through it. We will put them on the website, as I mentioned before, and you can study it, taking your time. So now we would like to ask 2 council members to give some comments on the inputs of the co-chairs. Well, to keep the order, I would like to ask Professor Jun Adima first. He's Professor for Energy and Environmental Policies at Tokyo University and former official of the Japanese Ministry of Economy, Trade and Industry. So please, Adima-san, your comment.
Thank you very much, Joanna. And having heard two presentations from Terazawa-san and Peter Hennique, I found a very interesting contrast with regard to the need of new gas investment. And Terazawa-san, on one hand, stressed the importance of new investment in natural gas throughout the whole supply chain, from upstream investment and LNG and so on. And on the other hand, Peter Hennique said no need for further sources of LNG worldwide, referring to the IEA's analysis from the World Energy Outlook. And having heard both arguments, I tend to agree with Terazawa-san, saying that because having attended the Asian Energy Ministers meeting, for example, East Asia Summit Energy Ministers meeting in September, there's a clear recognition of the need of further investment in natural gas, because as Terazawa-san emphasized, there was, the ongoing plan to switch from coal to natural gas in Asia to pursue a low carbon future. But this plan is very much disrupted because of skyrocketing LNG prices. And the skyrocketing LNG prices is caused by the rush by European countries, including Germany, towards LNG cargoes. So, already from last September, the world market is experiencing energy crisis, and it is caused by underinvestment. And the argument that there is no need of new further investment, upstream investment for oil and gas, assumes that the world community will definitely need carbon neutrality by 2050. But I tend to doubt about this assumption itself, because looking at China's target, 2060 carbon neutrality, and India's target, 2070 carbon neutrality, I do not think it is highly probable that the world will achieve 2050 carbon neutrality definitely. So that means there will still be the fossil fuel demand, and the fossil fuel demand and demand for a new investment would be larger than the assumed case in the IEA's analysis. So that's my first point. And my second point is, though Terazawa-san did not refer to this, but, there is a renewed interest in Japan. And the Prime Minister Kishida clearly said, we will consider not only restarting nuclear, but also the research and development and construction of innovative reactors. And I think acceleration of restarting nuclear reactors in Japan will indirectly also save global LNG market, because by restarting one nuclear reactors, that will free up 1 million ton of LNG. So I think acceleration of nuclear is further more important in Japan. So having heard Peter Hennique's presentation, I think, you are very much focusing on energy efficiency and renewables and phasing out of coal and nuclear, at least for mid to long-term perspective. But big difference between German approach and Japanese approach is, Japan is looking at more broader options, and the fossil fuel with CCS, and also nuclear is definitely, the arrow in our quiver. So that kind of contrast is very much interesting for our further debate. So for the sake of, time constraint, I will stop here. Thank you very much.
Yes, thank you very much for the brief comment. Now, as Terazawa-san is ready again, I would like to ask him to just complete his presentation before we come to Felix's comment. So please, Terazawa.
Well, I'm sorry, there seems to be a network problem. So I think I left at this slide. So just quickly finishing my comment. I think I touch upon the left side graph. So looking at the right side graph, you can see the events in Ukraine and the development in Europe has affected the Asian countries. In particular, if you look at the right side graph, you can see Thailand's LNG import prices going up dramatically, it appears that Thailand was depending on a spot market, so they were affected by the recent developments greatly. So while I think the EU or European countries have been able to secure the expansion of LNG procurement, at the same time, you can see that resulted in the price hike for the Asian countries, which were dependent upon the spot market. Next slide, please. For Japan, we are facing a problem on our own. As I said, Japan has been benefiting from the existence of a long-term contracts, but as you can see from this graph, especially after 2029, the remaining long-term contracts will be dropping. So for Japan, since we have learned the risk associated with the dependence upon spot markets, we would have to ensure that we would have a sufficient level of long-term contracts to reduce our exposure to the fluctuation in the LNG market. Having said so, the difficulty is that the future for Japan's gas consumption is not so clear for various reasons, including the declining energy demand and the climate policy and the nuclear power, and also the competition in the power markets. So this makes it very difficult for Japanese companies to enter into long-term contracts by making long-term commitments for procurement. And we will also have to find the long-term usage for the added natural gas that we may procure. So in this regard, we believe that the decarbonization of natural gas by applying technologies such as hydrogen and CCS will be important to ensure that we will have the long-term usage for the additional LNG that we may develop. Next slide, please. And since Japan has so much uncertainty, and Japan alone cannot justify the procurement of LNG in scale, this leads us to the next question of the role of Asia. Asia, as you can see, has been dependent upon coal and oil, as you see from the right-hand graph, and they would have to make the transformation. And this is not easy, especially considering the limitation of Asia in terms of their availability of renewable energies, and they have to provide low-cost energy for the low-income people, and they have to meet their very strong energy growth. In that regard, we consider a two-stage approach is applicable for or realistic for the Asian countries by two steps. Step one is making the transition from coal to natural gas, followed by the step two of applying new technologies such as hydrogen, CCS to decarbonize their natural gas. But in order to realize these two-step strategies, we need to stabilize the global natural gas market, which can support both the energy security and the energy transition in Asia while preventing the expanded or extended use of coal. So the stability of the LNG and the gas market, and we need to work together with emerging and developing Asian countries to ensure natural gas demand that can ensure the necessary investment for natural gas and LNG, and we believe that this could help benefit the emerging and developing Asian countries by presenting a realistic and decarbonized path. And we also have to think about the long-term consistency with carbon neutrality, and that's where we believe that technological development, such as in order to avoid the stranding of the gas assets by introducing technologies such as hydrogen or CCS would be very important to ensure the long-term consistency with the carbon neutrality goal. So our policy is that for the first stage, we need to reduce our dependence upon LNG from Russia. In order to do that, we need to invest in non-Russian sources of natural gas and LNG. But at the same time, we need to ensure consistency with our long-term goal of carbon neutrality. So that's where decarbonization of natural gas will play a role. And that's where we think we attach great importance for hydrogen and CCS to make that happen. Sorry for the interruption, for the network problem, but Thank you very much for letting me complete my presentation. Thank you very much.
Yes, of course, very valuable information input here. So if the audience would give us some 5 minutes more for another comment from another outstanding expert from the GJETC, which is Felix Mattes. He's research coordinator for energy and climate policy at the Öko Institute for Applied Ecology in Berlin. So Felix, please, your comment.
Yeah, thank you, Johanna. Thank you, colleagues. I think if I would summarize the effect of the Ukrainian war on the German-Japanese cooperation, then it is a single sentence. The commonalities will be sharpened and the differences will be sharpened. And I think this is true, but if you have a look in the details, then it gets much more differentiated. And I would like to highlight a couple of points which are important from my perspective. The next slide, please. I think what is important from my perspective is that we need to differentiate 3 different challenges which are somehow interlinked, but which are different challenges. The first is the security of supply. So that means the physical supply of natural gas. You can see here what happened during the last 2 years in Germany. Russian imports disappeared and a lot of LNG via other European countries landed in Germany. So the issue of physical supply and safeguarding the physical supplies of natural gas to Germany is an important point. There are a couple of levers. Natural gas consumption decreased about 10%. We have increased imports and we have decreasing transits through Germany. But the second, and the next click, please. The second challenge, and that is somehow separated from the physical supplies, is the price development. You have seen these graphs in the last presentations, but what I added here are the future prices in the European markets. And you see here that there is a thing which I would call the Death Valley. So during the next 2 to 3 years, we will see major challenges with regard to gas prices, but also with regard to power prices. But we also see that there's a clear backwardation trend in the market. So in the second half of the 2020s, we will probably see much lower gas prices and much lower electricity prices. However, the new normal for the gas prices will be probably at the wholesale level, the double of the gas prices, but the triple of the electricity prices. And that comes due to the role of carbon pricing in the market. So the key issue is not only the gas prices, it's also about the electricity prices, and more important, the ratio between the gas prices and the electricity prices, which is a separate challenge which needs to be answered if it comes to the market design debate. Next slide, please. The other differentiation, which is important from my perspective, that we need to separate the 3 different time horizons. The next few months is the storage facilities are full in Europe and in Germany. Physical security of supply is not a major issue. So that means energy prices and energy costs are for the upcoming months the key vulnerability, and the key measures which have been taken are targeting energy prices and energy costs. And many of the medium-term processes and adjustments needs to take off in the next couple of months. This is somehow different in the next phase, which is the next 2 to 3 winters, where the preparation for a more integrated supply and demand management is important. So in Europe, the target is to arrive at 20% gas savings. We will see in Germany 3 state-owned and 3 private FSRUs with a capacity somewhere between 250 and 300 terawatt hours, which was in the old world of natural gas consumption a share of 25 to 30%. We will see see probably slightly increasing emissions, and we need to make major progress on the medium-term solutions. And then, and this is the most important point, in the next phase, and from my observation, there is a strong convergence between energy security in the new framework, under the new conditions, and the long-term measures which have been planned with a view to carbon neutrality by 2045 in Germany, in 2050 in Europe. So that means we will see benefits from the climate policies or climate neutrality policies with a view to security of supply. And that also applies to natural gas. If you have a look to the building sector and the heat sector and the decrease of natural gas in this section. This also supplies for the sectors where natural gas remains to be a transitional option. That is especially the transformation of the steel industry. I wrote this in the chat. There will be a major announcement of a support program, and natural gas will play a role in the transition for the steel industry toward direct reduced iron, and we will see some natural gas in the power sector. However, the transition towards hydrogen will be accelerated, and this is one of the major differences in the programs driven by the security of supply concerns. There will be an interesting announcement by the German government that blue hydrogen will also be subject to support if it comes to this transition of the steel industry, etc., etc. That means also the role of CCS in the transition process will increase. This is important because everybody talks about the climate neutrality by 2050 for Europe and 2045 for Germany, but much more important, if you look to the European Union emissions trading system, there the climate neutrality must be reached in 2039 according to the latest revision proposals on the caps. That means for the energy intensive industry and the power sector, climate neutrality before 2040 is on the agenda, and not only on the agenda, it is legally binding and safeguarded by very powerful instruments. And diversification, not only for energy, based on the N-1 principle, is important. Last slide, please. I think it is important to have a look on the structures of the integrated packages which have been approved in both Germany and the European Union to get across through the death valley of the next 2 to 3 years. We have 3 cost relief packages for Germany, which include short, medium, and long-term measures on energy efficiency and an accelerated ramp up of hydrogen, etc., etc. We have the short-term measures by balancing supply and demand by the fast-tracked FSRU commissioning and the acquisition of additional supply contracts. There we have an interesting debate on the duration of these long-term contracts and destination clauses. And we had the recommendations of the expert commission on gas and heat, where Carsten Joller and I had the honor to serve in. And it's important maybe to highlight a couple of things from the recommendations of the expert commission, of the gas commission. The first is, yes, we have this gas and heat price or better cost break, which is a compensation, but which does not remove the incentives of the high gas prices for energy efficiency. It's an interesting design of this gas and heat cost break, because it maintains a compensation for private consumers, SMEs, and industrial consumers by a lump sum compensation, and so maintains the incentives of the high gas prices if it comes to energy efficiency. There are some safeguards in the recommendations of the gas commission for industrial production sites as part of the gas price or the gas cost break. That means there is an obligation for those industry who take part in the gas cost break to safeguard the industrial production sites, and we have a market, we have a package for gas market stabilization if it comes to liquidity, margining, etc., because this emerged as one of the key challenges for the market. So not only the prices, but also the market stabilization is an issue in Europe. And we have also in the recommendations of the gas commissions a package of additional measures for reduction of natural gas consumption, but also with a view to the accelerated transition towards climate neutrality, with a view to electrification, and with a view to the transition to hydrogen. We have an interesting adoption of the gas cost brake in the electricity market. And as I highlighted before, the electricity price situation, not the security or system adequacy, but the electricity prices is a long-term issue because of the interaction between the gas prices and the CO2 prices. So we have a proposal on the electricity cost brake, which is very comparable to the design of the Gas Commission's proposal for the natural gas brake. The most significant difference is that skimming the windfall profits in the energy sector is part of the revenue generating part of the electricity cost brake, which shall contribute to the necessary financial reserves. And last but not least, we have a European Union package, which is important, which includes a European single buyer for natural gas, other gas market stabilization measures, and EU compensation funds, and the implementation of the European Green Deal. As I said this before, for the second half of the 2020s, there will be a strong convergence on the effects. That means the climate neutrality policy will.
Felix, you got muted. I don't know. Maybe because your time is running.
I didn't press a button, but this is my last slide. And if you click for another one, then I come to an end of my comment. Thank you very much.
Thank you very much, Felix, for this last, but really, really very interesting comment, I think. And it has become clear today, I'd say short-term reactions, but also long-term sustainable strategies are urgently needed in these times of crisis. Now we're coming to an end. I would like to ask all panelists and organizational staff and speakers to put their videos on. And to you, the audience, thank you for staying with us for such a long time. I hope you got an interesting insight also into the work of the GJETC. So this is how we work, how we carry out studies, how we share views, sometimes also controversial. And thank you also in the audience for your contributions in the chat. I think we could continue this discussion, and we will continue actually in the next outreach event, which will take place probably on December 9. You will be notified. And in this next outreach, we will try to connect the outcome of the ongoing COP27 with energy crisis policies in both countries. So I hope you will also be with us then. So thanks to everyone. Thanks also to the interpreters who did a great job today. And thanks to the funding institutions of the Council, the German Federal Ministry of Economic Affairs and Climate Action, and the Japanese Ministry of Economy, Trade and Industry. So thank you very much for joining us and hope to see you next time. Thank you.
Thank you.
Bye-bye.